So with melting points, is it the same principle that if they are filled up in their valence electrons, that they're going to have a higher melting point?
If they're all filled up in their valence electrons?
Right, because, for instance, like it gives SRO, RBF.
Okay, so SRO,
Yeah, and then
RBF.
Yeah, and then strontium, and then F2, whatever F is, fluoride. Fluorine. Okay.
So let's look at the charges that we're dealing with.
Okay, so strontium is 2 negative,
2 positive.
2 positive. Excuse me.
And then O is 2 negative. Rubidium
It is positive 1,
and fluorine
negative 1.
negative. Okay,
Once again, 2 positive,
so this guy is SR 2 positive,
and then F2 negative.
F negative. Okay, so this is what we're seeing. This guy, he's basically, they're sharing, or they're among these two, there are 2 electrons. Okay. Let's say that these bond levels, these charge levels, are the arms that you're using to hold on to each other. Okay, so this guy, he's holding out with 2 arms, this guy's holding out with 2 arms.
Mm-hmm.
Okay? Like this, 2 hands, super strong.
That's pretty strong. Yeah.
This is going to have the highest melting point. Okay?
Yeah. Next one is just like 1 arm.
This one, each one is extending 1 arm. 1 arm, 1 arm. Okay, so this is probably going to be the lowest. Because this guy right here, we see that one guy is holding out with 2 arms, but the other guy's only holding on with 1 arm.
Now, even though it's an F2, we just ignore that, we just simply look at the charges, correct?
Yeah, we just look at the charge, like he's holding towards each one.
Right, so basically that's an accumulated 3 arms, the other one's 2 arms, and the other one's 4 arms.
Mm-hmm.
Okay. That makes sense. Okay. And so we basically just ignore the fact that it's F2.
Yeah.
Okay.
Charges take dominance.
Okay.
And then, like, if there are similar charges, then we look at the mass.
Could I give you one that I think would be even stronger? What about like aluminum phosphorus?
Oh, yeah.
Because that's 3 and 3, correct?
Yeah.
Okay.
I would think that would be, I don't know if that's something that actually
It's possible,
exists, but if it did, that sounds like something that they would coat space shuttles with.
because it's that strong of a bond.
Yeah, and it wouldn't melt. It would have a super
Wow.
high temperature.
That's pretty cool. That's interesting. All right, you got that right, James. Good job. And then this one, for build a 2-dimensional crystal that contains 6 formula units of sodium chloride in the solid state. Now, they showed us, reading the chapter I saw like the crystallization structure and things like that. And almost always they have the negative in the top corner, don't they? And then they kind of just alternate.
It doesn't matter.
It doesn't matter. Well, you just ruined my entire theory there. All we simply have to know is just that the negative's bigger. And
Yeah, the negatives will always be bigger. But the thing is that for this, the way that you're going to place them is that they're always going to be positive, negative, so that there's never 2 that are the same that are touching.
gotcha. Besides diagonal.
Mm-hmm.